This is a demonstration video looking at how easy it can be to recycle aluminium. Aluminium is an element on the periodic table. It is a lightweight metal and is a common element on Earth, making up roughly 8.23% of the Earth's crust by weight. Historically, aluminium is a difficult metal to extract from the oxide or ore due to the challenges of removing the bound oxygen. In fact, these early challenges of extracting pure metallic aluminium made aluminium an attractive option to form the capstone on the Washington Monument. Today, aluminium is frequently used in a wide range of applications. These may include vehicle parts, pots and pans, and aluminium drink cans. And within this demonstration, we are going to try to recover some scrap aluminium in the form of aluminium drink cans and melt this into aluminium ingots. So before we start melting our scrap aluminium cans, we're going to melt some larger pieces of aluminium. These I saved from bits and pieces. An old aluminium dive torch. I'm going to melt this, and this is going to create a heel melt in the crucible before I start putting in the aluminium cans. Having this heel melt present in the crucible should increase our recovery yield. So here we have some crushed scrap aluminium cans, crushed to a size where they will fit inside my stainless crucible. So right now I have molten aluminium in the base of the crucible, and as I introduce the aluminium cans you can see some fire. This is a result of the plastic lacquer burning. Noting that the cans are coated on the inside to prevent the beverage reacting with the aluminium, and on the outside to present a nice label. Unfortunately, that doesn't add to our molten aluminium. The plastic burning was a little more intense than I expected, so I moved the process outside. And I'm plunging the aluminium cans under the melt to try to get the best recovery from the aluminium. The furnace that we are using is electric, so we're using an electric power meter to monitor how much energy we are consuming in melting our aluminium. If it was possible for me to set up an extraction process to extract aluminium from aluminium ore at an industrial scale, I would expect to have to use around 10 to 15 kilowatt hours of energy per kilogram of aluminium extracted from the ore. However, we are recycling, so I expect significantly less energy to be consumed per kilogram of aluminium recovered. On pouring the molten aluminium into a mold, I'm using a steel bar to help separate off the oxide layer, which will be on the surface as dross, from entering the mold. So in this demonstration, I'm using around 160 aluminium drink cans of various sizes with an average weight of around 14 grams. And the heel that I made in the crucible initially was around 200 grams of scrap aluminium. And in total, I've recovered 2.153 kilograms of aluminium in ingot form. And the amount of electrical power I've used to cast all those ingots is 2.85 kilowatt hours. So if we look at all those exciting numbers, even recovering aluminium on this small scale, we have used around 1.32 kilowatt hours of electrical energy per kilogram of aluminium extracted, compared with 10 kilowatt hours of aluminium extracted from ore at an industrial scale. That means we've used around 13% of the energy required per kilogram to recycle aluminium. And now we're going to make something directly from one of our cast aluminium bars. Note the solidification void in the top of the casting. This is generated as the metal solidifies. There is a contraction. So using a mill, we're machining our aluminium ingot into a cuboid with flat faces. It is worth noting that this is cast aluminium. It is not going to be as strong as wrought aluminium, but for the product that we're going to make, that's not an issue. So we've cleaned up our aluminium ingot, we've squared the faces, and we've sectioned this into little cubes, and now we are laser marking our cubes with aluminium. And if you want to have a chance at winning one of these lovely cubes, please leave a comment in the comment section below. At the end of June 2025, I will pick one at random and mail them a cube. And as always, please subscribe and thanks for watching.